Greetings, Mathies. Well, today we are going to do the second type of solving for system of equations called substitution. Here we go. I could kind of figure out that one. All right, so let me get my screen set up. And we'll get going here. So we have learned how to do solving system of equations with graphing. Now what you're going to find out is the next two that we are going to learn definitely will be a lot more accurate. Graphing works if we know that our point of intersection is at a specific location that just involves integers. But when that intersection involves decimals, it is really hard to do it with graphing. So this is going to be a lot more accurate answer. Okay, now you're going to see that the notebook is just the same. All right, so go ahead and open it up. Here's our two equations. Now notice that this one is in standard form. I'm just going to put a little SF there. So this one's in standard form. The second one, I don't even know what form it is. It's not considered slope-intercept, but x is solved by itself. And so we're going to go ahead and substitute the 2y minus 13 in for x. Now this is really going to be a step-by-step process. And so just take your time on it. I hope you're listening to it. Because once you get used to it, it's not so bad, but it is going to be a multi-step process to get our answers here. Remember, the goal is to figure out the coordinate, what x is equal to and what y is equal to, where these two lines will intersect on the coordinate system. Okay, so when I substitute that in, I'm going to put a 2, parenthesis. Remember, variables have parentheses. So when I substitute in that 2y minus 13, I have to make sure there's parentheses around it. Now I just write the rest of the equation, plus y equals negative 1. All right, so just let that sink in. So again, the only thing I changed is I substituted, remember the original equation is 2x plus y equals negative 1. I substituted in for x this 2y minus 13. Now the reason we want to do that is now we have just the variable y. We can solve for that and find out what that is. When we have two variables, we cannot solve for either variable. Now sometimes we have to distribute, and that's what we're going to do first here. 2 times 2y is 4y, minus 2 times 13 is 26. We bring down this plus y equals negative 1. So now what I'm doing is just called simplifying, and then eventually get your like terms together. Here's a 4y and a y, so it's back to solving equations from first semester. So you can see why it's really important you know how to solve equations. 4y plus y is 5y. Those are like terms. Minus 26 is your constant, equals negative 1. Now it's down to a two-step equation. I'm going to add 26 to both sides. Bring down your 5y, and that equals 25. We'll divide by 5, and y equals 5. Okay, now what I'm going to do is I'm going to make an ordered pair right here. Y is 5. Remember, our ordered pair is always x. Just a second here. Is always x comma y. Okay, so now we need to find what the value of x is going to be. So here's what we do. I just kind of call it swinging it. We're going to swing this back up and substitute it into what I had circled. So I have x equals 2, remember variables have parentheses around them, 2 times 5 minus 13. solve for x here. 2 times 5 is 10, minus 13. 10 minus 13 would give us negative 3. Now that's our x value. So right here is the official answer. So we need to know both the answers for x and y both. A lot of times students will stop once they get one of the coordinates, and they'll forget to substitute back in so that we get an ordered pair for an answer. Now what I'd like you to do is, when you're working on these type of problems, is then use Desmos, type those equations in, and see if that indeed is where those two lines are crisscrossing each other. All right, let's move on to the next one. So this tab says no solution. All right, so let's see what happens on a no solution. Again, now this is in standard form. This one actually is in slope-intercept because it's y equals mx plus b. Okay, it's in that form. Now, because we have y isolated, I'm going to circle this and we're going to substitute it in for y. Okay, make sure there's parentheses there. So it's just a step-by-step process. I'm going to rewrite this equation and substitute this in for y. So I have 4x minus 3. Substitute this in. That equals 15. All right, now you kind of know if you substituted in correctly because all I have is the letter x. If I still had an x and I had a y, I know something didn't go correctly as far as substituting, but we're okay. All right, I'm going to bring that 4x down. I'm going to distribute the negative 3. Now 3 divides 3 once. Okay, so this would be like a 1 underneath. 3 divides 3 once. And so I would just be left with minus 4x. Negative 3 times negative 7 is a positive 21. And that equals 15. All right, so we would solve. We want to simplify first, get like terms together. Oh, look at what happens. 4x minus 4x. It's like they eliminate each other. And we're left with 21 equals 15. Okay, that is not true. So when that happens, that's going to be a no solution. So actually, this was a pretty quick problem. Now, what a no solution means from the graphing is that we would have two parallel lines. So when we would type these two equations into Desmos, what's going to happen is there'll be parallel lines and they would not crisscross each other. Last situation, many solutions, okay? So a no solution kind of look like this. So what's your prediction on an all solution? All right, let's see what happens. This first equation is in slope-intercept. This one is in standard form. So we take the slope-intercept equation and we're going to substitute that into the standard form equation. Okay, so I'm going to circle. That is going to go in for y. Now, sometimes it can go in for x, like our first example. Okay, so we just kind of have to look to see what's given to us. See what's isolated first. We're going to rewrite this equation. Remember, variables have parentheses. So important to remember. X plus 2, this is that coefficient. We're going to substitute in negative 1/2 x plus 4, and that equals 8. Bring down that x. Distribute. 2 divides 2 once. We're left with a negative x. 2 times 4 is 8. And you probably made this prediction. Now when we solve this, again, our x terms, they end up canceling. X plus a negative x, that cancels. Oh, but we get 8 equals 8, which is a true statement. And so that's why it's going to be all solutions. And sometimes what you end up seeing is that infinity symbol. So again, from the graphing, and this is why we did the graphing first, these two lines would end up being the same line. And so when you use Desmos, they'll just end up being right on top of each other, the same exact line. Okay, go ahead and glue that into your notebook.